Today we're going to talk about web security, specifically around content security, cross-site origin requests, and cross-site scripting. We're going to talk a little bit about web application firewalls and how they can help in these areas. Hi, I'm Don Bowman with Agilicus. And remember, if you like this video, subscribe to us on YouTube. Thanks very much. So first of all, Web Security 101. For security, everybody says, do what I want and nothing more. That's what you have in mind. But when you have a website, there's so much active content. JavaScript, your image techniques now, like SVG, can be active. You've got JSON-P content, CSS, tracking pixels. You've got buffer overflows, flaws, JPEGs, PDFs, ActiveX. There's so many different things. It's hard to express what I want and nothing more. And I guess it's a lot more complicated. So on the right, in the bottom, I don't know if you recognize this, but one of the first quickly propagating worms on the web was this thing called Sammy is my hero. And it was kind of hilarious. It happened in the area of MySpace. And Sammy recognized that he could change his profile to be something that if you opened his profile, you would see it, and it would add him as a friend, but then it would also add that to your profile. And very rapidly, Sammy became the hero of everybody on MySpace, and shortly after that, he went to jail. So Web Security 101, what are the tools of the trade? So the basic toolbox is the content security policy. Now, this is relatively new. Not a lot of sites have it, but what it does is it allows a site to assert, this is what can be hosted on me. These are where my fonts come from. These are the frames I allow, things of that nature. The XSS headers, the cross-site scripting headers, these indicate where scripts can come from and to from your site. CrossOrigin request sharing. This allows you to, if you're an API, to indicate who can use you. HTTP strict transport security. This indicates that your site can only be used over HTTPS. Of course, the TLS or SSL setup of the site. And then there's a thing that not a lot of people use called the DNS Certificate Authority record. And what that does is indicate which SSL certificates can be signed onto your domain to prevent somebody from signing a different one. And my thesis is fairly simple. If you come to a website and it doesn't use these basics, probably the more complicated bits aren't going to be well handled either. So, if you haven't got the 101 level right, then the 200 and 300 level is going to be very, very poor. So, content security policy. This is actually both very simple and very complex at the same time. So, imagine that you have a site that you've created, and you've got a couple of images, you've got a couple of fonts, you've got some CSS, you've got a little bit of JavaScript. Almost immediately, any non-trivial site, some of those things will be fetched from third parties, from CDNs. If you're serving ads, there's going to be things coming externally. And what you're worried about is user-generated content, and you're worried about the security of those third-party CDNs. So you could be very, very simple. You could just have a single header that says default source self. If it doesn't come from me, it's blocked. But it's really difficult to get away with that today. So here's an example down the lower right of why this is important. And this came from Whois. So Whois is a service that you can use to look up who owns some domain. And some clever person figured out that the text record could have a little bit of active HTML in it, in this case an iframe. In this case, the iframe opens up YouTube. And for those who don't recognize it, that's the Rickroll URL. And what happens is you go to a web browser that serves Whois via web, you type Whois, this domain, and you get Rickrolled. Now that's fairly innocuous, but imagine this was an advertisement being served on a site, or this is a WordPress domain that you host and somebody's put this in a comment. It could be a lot more damaging. The users of your site could see something much worse than Rickroll. So the content security policy fetch, what this does is it tells a user, a browser of your site, what you intend. You as the owner of the web page say, I want the following, and the browser should follow that, and if something comes along that disobeys it, then it gets blocked. And it gets complicated when you think about all the different types of active content that are on a website. So there's connect. Connect means a net JavaScript thing, where can it send an outbound request to? And this would be used to exfiltrate data from the browser. So if the user's typing in their Visa number, it's going to send the clickstream back somewhere to be interpreted. Frame source, these are what sites you can frame into it. So are you going to include YouTube inside it, etc.? Media scripts, where your JavaScript comes from. The style sheets, the CSS. Style sheets are actually more dangerous than people think. You can use them to guess at letters in passwords. Worker source, so if you're using a progressive web app, where is the web worker allowed to come from? The default, if it can't figure anything out, what's going to fall back to? Where can images come from? Images, there's a lot of malware out there, Chrome extensions and so on, that modifies your site a little bit to place ad banners in it, and this is your primary protection. You don't want graffiti on your site. Object source, there's not a lot of objects out there anymore. I don't really see the point in them. Flash was kind of the last one there, and then so on through these. As a developer of a website, you have to understand the tree of events that you want to occur. And it gets very difficult when you have third parties. And it's easy to throw up your hands and just put in star, but that's really not the best. So, if we look at the doc policy, this controls the document basics. Where can it come from? The base URI, what can be in that base record? What plugin types? Sandbox, do you trust it a little bit? We want to avoid adding things like Flash to our sites. We really want to try to protect our users from bad ads and so on. The Nav policy, this controls the document navigation. So form actions, when you click username and password in a form and it posts somewhere, it's going to navigate away. That could be your username and password. Frame ancestors who can embed us, navigate to, where we can navigate, away from our site. We really want to prevent click stealing. You think about this a little bit when you put your site together. So the summary of content security policy: you're never going to be wrong if your default source is self, but it may be very difficult to make a very interesting site. You're going to be encouraged by a lot of software you use to just turn on unsafe eval and unsafe inline. And I think those names should give you a little bit of pause. It's basically self-modifying code. And like we were all taught back in the day in computer science, self-modifying code, although kind of fun and kind of powerful, is actually kind of dangerous. And unfortunately, it's needed for a lot of things. If you're still using Angular.js, even though it's quite old, you may find that you need to turn these on. But if you're using modern Angular, you can use sub-resource integrity and ahead of time compiler. You can have hashes on everything, and you can turn off unsafe inline. If you're using WordPress, it's still not there yet. You're going to have not a lot of choice in the matter. But you have to put some effort into this and put some policy. Otherwise, you're just writing a blank check for some hacker to do something malicious on your site to your users. And you don't want that. The XSS headers, so these are a little bit more legacy now that the content security policy is here, but they're still used. Some browsers only use these. X content type options. So back in the day, you would click on a link and the file would end in .xls, and the browser would try to guess, oh, that means Excel, and I know what to do with that. I'm smart. And the problem there is people could end up influencing the user to click on something that'll run locally that they hadn't intended. So what we do with this option is we tell the browser, don't guess. I either know the MIME type and I tell you, or just it's a file, just download it. Don't try to open something magically. The X-frame options, this indicates whether we can be embedded in an iframe. And this is one of our primary forms of security. If somebody else comes along and they embed our site in a frame, they can catch our clickstream, but the user may not know they've been embedded. The XSS options, really this is obsolete now with CSP, but if you have to support an old browser, you would still use it. So the too long didn't read here. If you just set these headers to X content type options is no sniff, X frame options is deny, and XSS protection is 1, mode equals block. If your site still works like this, then move on. If it doesn't work, try to fix it so it does work like this. CrossOrigin request sharing. So this one I really struggle with. It's very difficult to use. I'll give you the example use case for it. So there's a tool that I use called MailChimp. It's a mailing list manager. And you can get what's called an API key for it. And the API key allows you to use it programmatically, add people to the list and so on. And if you weren't that smart, if you weren't thinking ahead, you would end up with that API key would be in the JavaScript because you want to do it from the client side, right? The client is going to come along in their browser and they're going to click on, yes, sign me up to this list, and you just use the API key and you sign them up. Of course, that means that the API key is in the HTML and anybody can sort of right-click, view source, see it, and they can go, change your mailing list, add users to it, delete it, pull them from it, etc. So that's actually very dangerous. And it wouldn't be MailChimp's fault. It would be your fault for doing something insecure with that API key. But it's really tempting. It's really easy to do because if you don't really think it through, it seems right. So what they do is they just flat out block course. You cannot access the MailChimp API from JavaScript, and that prevents you from accidentally doing this dumb thing. You got to do it from the server side, which doesn't obey course. That being said, as somebody who makes a set of safe APIs that use bearer token authentication, that I don't really know how to use this properly, and we're very tempted just to turn it off or to set it to the domain you're coming from, sort of magically on the back end. You're going to see something called a pre-flight request triggered in your browser, and the pre-flight request, it's kind of a fake request that tries to do an options request to this. If it's blocked, the JavaScript cannot detect that it's been blocked, but it also doesn't run. And that's what the symptom that you're going to see here. There's no wildcarding present in CORS, and that makes it really difficult to use. Really what it is saying it's like a who can call me list. So you can say access control allow origin star, or you can say access control allow origin a single site. You can't do anything in between. You can't have a list, and you can't have wildcards on domain names. So if you have an API and it has bearer token authentication and you're not hard-coding some secret in the app, I think you want this star. If you're using Istio as a service mesh, you can convince it to dynamically set this value so the site they come from is what you tell them they can come from. Not really sure what value is created there, but it does work. So let's talk a little bit about some case study here. In 2018, Marriott was compromised. 500 million guests. Everybody had stayed there for 4 years. Guest records, passports, credit cards, CEO called to testify before the U.S. Senate. So you would think that after that exceptionally embarrassing event, they would have done a great job on the front door of this. www.marriott.com must be the Fort Knox of websites, right? Nope, not even close. So I use a tool called RequestMap, requestmap.webperf.tools. It's quite great. You go to it, you type in your domain name, you pick a runner, you choose on it for a little bit, and it shows you a tree of everything that gets fetched by the user when you go there. Look at this site. Oh my God, it's so deep, so wide, so many requests, so many different domains. You're only as strong as the weakest of those. Any one of those is running in the full security of that website and can change the user's experience. They can change an image they see. They can change... you can look at a password, you could put graffiti on it, anything you wanted. It would be just terrible. Why would you do this if you're Marriott? Why would you have so many trackers from so many domains it's very difficult for me to understand. So what has Marriott done here? They've done nothing. They haven't even given it a shot. The tool on the right, the screenshot, is the Mozilla Observatory. I highly recommend this. It's a really, really simple tool. It gives you a very basic 101 level of the security of a website. Don't take it as gospel. If it comes back A+, don't come back to me saying, hey, this site turned out to be insecure. But it's a really quick check as to whether it's good, bad, or ugly. Marriott's done nothing. No content security policy, no secure flag on cookies, no strict transport security, no sub-resource integrity, no content type options, no frame options, no XSS protection. They've literally done nothing. They lost all the records. They testified publicly on the subject, and then they turned around, and the front door, the main page of their brand, they did nothing. I think any one of us can do better than this on our sites. So let's talk about state. So when the web was originally envisioned, it was an entirely stateless activity. You opened a web page, you viewed it, you moved on to the next web page. There was no state when you went back to it. It didn't know you'd been here. And then along the way, we invented the first level of state called a cookie, because websites wanted to keep track of you for some reason. Are you logged in? Have you been here before? Do you have a shopping cart open, etc.? And then along the way, people started to realize that cool stuff was stored in that state, and if you snooped it, you could detect things. So, a competitive site could look in your cookie, and they could determine what you were trying to buy at their competitor, and they could give you a discount on it, etc. So we started to add protection. We just started to say, okay, well, maybe cookies shouldn't be read by JavaScript. Maybe they should only be on HTTPS and not HTTP. Maybe we shouldn't supply them to non-HTTP protocols like SMTP or something. And we started to add each of these check marks, the secure flag, the HTTP only flag, the same site flag, etc. In the Marriott case, just didn't bother. But, you and I, try to minimize the use of cookies, ideally to 0, but if you have to have 1, make it encrypted on the server side so the client can't do anything with it, and then make it secure HTTP only and use a host prefix so it only goes back to the host that it came from. So let's check TLS CAA. So CAA, this is a record you put in your DNS, and in a nutshell it says who's allowed to create a certificate for my site. So if we look at Marriott, again, they don't have the CAA record. They also don't use DNSSEC, so you could spoof their DNS in some way. They don't use HTTPS, strict transport security. You can go to their site in HTTP only. Again, they're going to take the position this is only read-only marketing material and it's not that important. But I think that if somebody was to graffiti up that site, they would probably change their mind in a hurry. If you look at sites that do have a CAA record, like I use one, it prevents some accident from occurring at some certificate authority where somebody masquerades as me and they get my certificate. And you'd think, oh, well, that could never happen. The CA authorities are well run, but Symantec lost their license to run their CA because they made some mistakes. Other people have made mistakes. There's this sort of a panacea called a web application firewall. And the idea is you buy this and it just sort of scrubs away all the bad in all the web applications you have and you're great. To a certain extent, it's true. I mean, it does get rid of entire classes of vulnerability. It scrubs them out. But it really is a Band-Aid. It's a magic regex unicorn. And you just end up putting more and more and more rules in here for each of the well-known security flaws. The right way to use a web application firewall is to buy you some time. So I've got a 2-layer defense in depth. My WAF blocks all of entire classes of flaw, and I constantly keep my backend up to date to make sure it doesn't have those flaws. But if I make a mistake or I'm not timely enough, the WAF fixes it. That's the way you should think about this. If you're trying to fix all of your errors solely in the WAF and you're writing Lua code and regexes, you're going to make mistakes here because it's very difficult to do. But I was challenged with this from a customer earlier last year, and they had a tool that it just didn't do the login properly, and they wanted to make sure that after the user had logged out, the access token was revoked. After they'd logged in, they could access files, but you can only access files if they were. You started to create these very complicated rules like this, and it becomes difficult to maintain, but it is pretty powerful. So here's my call to action. In 5 minutes, just by opening Mozilla Security Observatory, we were able to assess the security culture of Marriott. The front door of the building isn't protected. It's not that they've done a bad job, they just haven't tried. If you get this wrong, why would you trust the rest? So my call to action is adopt a site, one you own, one that you use and care about. Check it. Go to the Mozilla Observatory, give it a quick check. And if they've tried and they've got a score other than an F, assume that they've done the best they can, and maybe they have a WAF fixing the rest, or maybe the rest aren't pertinent to their domain. If they've done nothing, maybe it's time to notify that owner. Hey, are you familiar with this new standard called Content Security Policy? Do you really want your site to be embedded as a frame in something else? Fix a site you own. The 80-20 rule applies. You can get 80% of the way there with 20% of the effort. Just do a little bit of research on content security policy, think about each of those tags, put a restrictive one in, turn the report on, see what breaks, fix it a little bit. You'll be better than most of the sites out there, and therefore you're not going to be the attack vector. And then teach someone else about it. So that's what I'm doing here, and that's what I'm asking you to do. Now that you've learned a little bit about this, become an ambassador. Hey, web security is not that complex to do the very basics. Let's get the basics right. this isn't talking about SQL injection and complex backend behavior. We're talking about just a couple of headers here instructing a browser how to behave. Do what I say is the security that I want. How do you say it? You say it with these headers: content security policy, cross-site scripting, and course. So thanks very much, and I hope you enjoyed the video. And my name is Don Bowman, and I'm from Magillicus. Bye-bye.